Hi everyone, for today's lesson, we are going to prove properties of parallelograms. Before we get started, please make sure that you have already completed the vocab video lesson where we discuss coordinate proofs. And a coordinate proof is where you take a figure and you put it on a coordinate plane, and I tell you what that figure is. So I might tell you that it's a parallelogram, a rectangle, a rhombus, or a square. And I'm going to ask you to prove a property of that figure. So I might ask you to prove that opposite sides are parallel of this parallelogram, or that opposite sides are congruent, or that opposite angles are congruent but maybe not right angles. I might ask you to show that the diagonals bisect each other. I won't ask you in this lesson or in the remainder of this unit to prove that consecutive interior angles are supplementary. That's just not something that we do. So I want you to be aware of that. But let's say that we were talking about the properties of rectangles or rhombuses or squares. Like if I was asking you, I told you that you have a rectangle and I want you to prove that all of the angles are right angles, or that all of the sides are perpendicular to each other, or that all of the diagonals are congruent, etc. So you are going to be asked to prove a property. And the way that you're going to prove a property is you're going to use either this distance, slope, or midpoint formula. If you want to prove anything that includes the word congruent, like that sides are congruent or that diagonals are congruent, you're going to use the distance formula to show that. And you're going to look for certain sides or segments to have the same distance or the same length. If we are asked to prove prove that opposite sides are parallel or that they are perpendicular, you're going to be using the slope formula. So, or you might see that they have right angles. Right angles are perpendicular lines because we know that perpendicular lines form right angles. And therefore, you're going to be looking for parallel, perpendicular, right angles. All of those pieces indicate that we're going to be working with the slope formula. So if we are looking at opposite sides being parallel lines have the same slope. They have equal slopes. So you're going to want to look for sides with the same slope. Let's say that we are talking about perpendicular lines, or proving that two lines together form a right angle or that they are perpendicular to each other. You want to look for sides that have opposite reciprocal slopes. So as a recall, opposite reciprocal slopes means that the slopes are different signs. So one is a positive, one is negative. And you might see that one has a fraction that's like 4/3 and the other one's 3/4, where the fraction has been flipped. So opposite reciprocal is where you flip the fraction, switch the sign. And these are examples of opposite reciprocal slopes. Finally, if you are asked to prove that the diagonals bisect each other, that means that you're going to work with the midpoint formula. And what you want to show is that the diagonals have the same midpoint. So this is everything that we want. These are all of the ways that we are going to be using our properties. So let's go ahead and get started with our very first problem. So in example 1, it says, write a coordinate proof to show the following properties of the parallelogram. So they're telling us right here that this is a parallelogram. So we know that from the very beginning. And we want to prove that both pairs of opposite sides are parallel. So if we're working with trying to prove that opposite sides are parallel, what we want to show is that opposite sides have the same slope. That's what we want to show. We want to show that opposite sides have the same slope. And whenever you're doing a coordinate proof, we always start off by writing out the formula that we plan to use. And since this is parallel, remember parallel, perpendicular, right angles, that indicates that we're going to be working with our slope formula. So we always write out our formula. That's going to be y at like lowercase little m is y2 minus y1 divided by x2 minus x1. We always write out the formula. And looking at our figure right here, we want to show that both pairs of opposite sides are parallel. So I like to color coordinate, and I'm going to work with the green sides. These are opposite sides. So I'm going to identify the slope of WZ. That's down here. And if it's helpful for you to label x1, y1, and x2, y2, go ahead and do that. If it's not helpful, then don't worry about it. Just do what makes sense for you. So I'm going to write 0 minus 0, so that's y2 minus y1, divided by 6 minus 0, that's x2 minus x1. We end up with 0 over 6, and 0 on the top is okay, but 0 on the bottom, no way. So therefore, this ends up being 0. Next, I'm going to go ahead and look at the slope of my other green side, which is x and y. So we're going to find the slope of xy. And I'm going to label once again x1, y1, and x2, y2. And y2 is 4, so 4 minus 4 divided by x2, which is 8, minus x1, which is 2. So we end up with 0 over 6, and once again, that's 0. So what we have just shown is that these green sides have the same slope. So now let's go ahead and look at our other side. So I'm going to use a different color, and I'll call this side the yellow side. And we're looking at the slope of WX. And if it helps to change one of these to x2s and y2s, go ahead and do that. So I'm going to find the slope over here to make this y2, which is 4, minus y1, which is 0, divided by x2, which is 2, minus x1, which is 0. So this is 4 over 2, which is 2. So now I'm going to identify my next slope, which is my yz. And in this problem, I'm going to change down here to x1 and y1 so that I end up with 4 minus 0 divided by 8 minus 6. So I end up with 4 over 2, which is once again 2. So I've noticed that opposite sides have the same slope. And since the slope of WZ is equal to the slope of XY, and the slope of WX is equal to the slope of YZ, we can therefore say that both pairs of opposite sides are parallel. And what this is it's just a restatement of what we were trying to prove. And what we're writing right here is what we observed. We observed that these two slopes, opposite sides, have equivalent slopes, and the other opposite sides have equivalent slopes. So you can write it out in words, or you can write it out in symbols. Let's go ahead and look at letter B. In letter B, we want to prove that both pairs of opposite sides are congruent. And whenever you see the word congruent, that indicates that we are going to be working with the distance formula. And what we want to do is we want to show that opposite sides have the same length. Show that opposite sides have the same length. That's what we want to do. So we always start off by identifying our formula that we plan to use. And in this case, it's the distance formula. So I'm going to go x2 minus x1 squared plus y2 minus y1 squared. So this is part of the proof because it's telling us what formula you plan to use in order to prove your property. And once again, I am going to use color to kind of help organize myself. And I'm going to work with the green side, and then I'll work with the other sides. These two sides are opposite sides. And whenever we name, or whenever we're trying to find distance, we always use two letters, the letters of the segment. So I'm going to work with XY, and then I'll work with WZ. And we do not put a line above to indicate distance. And if it helps you to label x1, y1, and x2, y2, go ahead and do that. And if it doesn't help, then don't worry about it. Don't do that. Just do what makes sense for you. So here is x2, which is 7, minus x1, which is 5, squared, plus y2, which is 7, minus y1, which is 7, squared. So 7 minus 5 is 2. 2 squared is 4. 7 minus 7 is 0, and I don't really need to write anything because 4 plus 0 equals 4, and I know that the square root of 4 is 2. So now I'm going to find my other length down here, which is WZ. So that is going to be, if I label this x1, y1, and x2, y2, 2 minus 0 squared plus 0 minus 0 squared. So this is equal to 2 minus 0, which is 2, 2 squared, which is 4. 0 minus 0 is 0, so I'm not going to write anything down. The square root of 4 is 2. So both of these lengths are exactly the same. Opposite sides are congruent. So now I'm going to look at the other pairs of opposite sides, WX and YZ. So let's talk about WX. I'm going to label up here X2 and Y2 to help with my organization of putting these values into the formula. So I have X2, which is 5, minus X1, which is 0, squared, plus Y2, which is 7, minus Y1, which is 0, squared. So this is equal to 5 minus 0, which is 5, 5 squared, which is 25, plus 7 minus 0, which is 7, 7 squared is 49. 25 plus 49, that's going to be equal to 74. And 74 is doesn't have any perfect square factors, so we're simply going to leave it in simplified radical form of the square root of 74. Our last side that we need to look at is YZ. And I'm going to change one of these, make up here X1 and Y1. And I'm going to put those values into my formula. So I have 2 minus 7 squared plus 0 minus 7 squared. So 2 minus 7 is negative 5. Negative 5 squared is 25. So I'm going to write 25. Plus 0 minus 7 is negative 7. Negative 7 squared is 49. And once again, we end up with that square root of 74. And both of these distances are the same. So what we're going to say is since segment XY is congruent. Now we can say they're congruent because they have the same length. Since XY is congruent to segment WZ and segment WX is congruent to segment YZ, we can therefore say that both pairs of opposite sides in WXYZ are congruent to each other. So what you're writing right here in your conclusion is since. Talk about what happened. What did you notice? We noticed that opposite sides were congruent, so you call it out for what you noticed. And therefore, you're basically rewriting what you were trying to prove. Both pairs of opposite sides are congruent. All right, let's go ahead and move on to the next page. Just so that you guys know, we're skipping letter D this year. So let's go ahead and look at letter C. In letter C, we want to prove that the diagonals bisect each other. So we want to prove that diagonals bisect each other. So when you see that word bisect, that indicates that we're going to be working with the midpoint formula. So what we need to do is we need to show that the diagonals have the same midpoint. So if you have a straight edge with you, you might want to use that straight edge to draw in the diagonals because the diagonals are not visible here. And for my people who are visual learners, you're going to want to draw those diagonals in. And if these diagonals bisect each other, that would indicate that these two segments would be congruent to each other, and this point would be the midpoint. Same thing with over here. If they bisect each other, that would indicate that these two segments would also be congruent, indicating that this point right here is the midpoint. Therefore, they would have the same midpoint. So whenever you see the word diagonals, you always have to draw those in. So we drew them in, and if they bisect, that means we're working with the midpoint formula. So we always write out the formula that we're going to use. So make sure that your M for midpoint is a lot bigger than if you're working with slope. Like slope is a lowercase m, and midpoint is a capital M, and that's because M represents an actual point, and we always use capital letters for points. So the formula for midpoint, remember, is x1 plus x2 cut in half, and y1 plus y2 cut in half. So we're essentially taking the average of our x values and the average of our y values. So I'm going to identify, I'm going to label x1, y1, and x2, y2, and I'm going to put these values into my formula. So this is the midpoint of xz. The midpoint of xz. So if that helps in terms of color, I'm going to be working with the yellow segment. So let's go ahead and put these values into the formula. We have 6 plus 5 divided by 2, and 3 plus 0 divided by 2. So this becomes 11 over 2 and 3 over 2. You can leave your answer just like that, or you can write your answer in decimal form, which is 5.5 and 1.5. But preferably, I would prefer it to be in fraction form. That's the way that I would prefer. So now let's go ahead and find our other midpoint, and that's finding the midpoint of the green segment. And I'm going to label x1, y1, and x2, y2. And I'm going to put these values into my midpoint formula. This is finding the midpoint of wy. So that is going to be 0 plus 11 divided by 2, and 0 plus 3 divided by 2. 0 plus 11 is 11 over 2, and 0 plus 3 is 3 over 2. You can also write that as 5.5, comma 1.5. But like I said before, I would prefer that your answer be written with fractions. So what do we notice here? Both of these midpoints ended up being the same. So since segment XZ and segment WY have the same midpoint, this is just a way of writing it out in words. You could also say that the midpoints are equal to each other if you would like to do that. Since they have the same midpoint, we can therefore say that the diagonals of WXYZ bisect each other, which is just another way of restating what we were trying to prove. And that is the end of today's lesson. If you have any questions over anything I talked about today, please feel free to email me. Otherwise, I hope you have a wonderful day.